This preparation is about bonds. So bonds are a way that large companies and governments can raise money. They are a contract that pays the bondholder, that can be like an individual who buys the bond or a company that buys the bond, a contract to pay the bondholder specific amounts of money at specific times. And so those specific amounts of money could be semi-annually, quarterly, annually, generally more frequently than that, and then a lump payment at the end of the bond period. So consider an n-year bond. You might have a 5-year bond or a 10-year bond. That's the life of the bond. You pay a certain amount P now to buy the bond. This is called the purchase price. Then you receive a future payment F at year N. Whatever N is, whether it's 5 or 10, you get a certain amount back. This is called the face value of the bond, that amount. You also receive an annuity, A, per year, and we call those dividends. Sometimes we calculate them, sometimes it's a flat rate, but sometimes they're calculated as a coupon rate on the face value. They can also be that fixed amount. It could be, you could say it's just going to be a $50 dividend semi-annually, or you could say that the coupon rate is 5% semi-annually on a $1,000 bond. Those two things would be basically the same. It's called coupon rate because back in the day, when a person bought a bond, they'd receive a coupon book, and they would exchange that coupon at certain times for their payment, for their dividend. Okay, so you pay a certain amount P now, you receive a future payment F, the face value at year N, and you get these dividends on a regular basis. So let's do an example. What kinds of problems do we ask about bonds? The most common ones are, we're going to ask, how much is a bond worth? What's its present value, basically? How much should you be willing to pay for the bond? And also, what is its effective yield, which is its rate of return? So a 5-year bond has a face value of $1,000. Think about it. Is that the amount that's paid for it, or the amount that they get at the end? It's the amount that's returned at 5 years. Coupon rate is 5% annually. What does that mean? That is the amount that is paid in dividends annually. Your money can earn 9%. So that's not something about the bond, that's the interest rate for the problem. And how much would you be willing to pay to purchase the bond? What's the bond value to you? Now, what you should be willing to pay, of course, depends on your own personal interest rate, and so it's going to be the net present value. And if you buy the bond for $800, what does the bond yield? What's the effective rate of return? So this problem here, we're going to solve by hand. This one here is since it's a yield effective rate of return problem, we typically need to turn to a spreadsheet for that. But we'll start with this one. What are we willing to pay to purchase the bond? Okay, so here's our problem up at the top. Let's get to solving it. So this 5-year bond has a face value of $1,000. So the face value, which is a future payment, F, is 1,000. It's a positive number because that's what we're going to get back. That's going to be paid at 5 years. Coupon rate is 5% annually. So this is not the interest rate from our problem. It's not I is equal to 5%, not that. Coupon rate is the amount that we're going to get in our dividends. So our dividends, which are an annuity, are 5% times the face value, F, is $50. And that's every year for 5 years. How much would you be willing to pay to purchase the bond? You should be willing to pay the net present value, because if you pay the net present value minus, well, we'll see in a second. Let's calculate the net present value. I'll make that assertion and then we'll check it. What's the net present value of this? 1,000 at 5 years, so that's a future times the discount factor P given F. With our 9%, I is equal to 9% in our case, interest rate, for N is equal to 5 years. Plus we've got an annuity, actually I'm going to write it here, plus an annuity, And we need the P over A factor, 9%, also 5 years. So this F here, this F is $1,000. You're all experts at looking up discount factors these days, so I'll skip that here. This discount factor is 0.6499. This annuity is $50, and this discount factor is 3.8897. You do all that math, you'll get that the NPV is $844. And I'm saying that this is the amount you should be willing to pay for the bond. Well, let's see this another way. What is the net present value? So, what is the net present value if I told you that we were going to pay a present amount, $844 for the bond? What would the net present value be then? The net present value would be P plus our F and times our P over F plus our A times our P over A. And so we'd end up finding this here would be negative 844 plus this amount here, which we also found to be 844. This would give us 0, which means that it would be exactly equivalent to our bank account earning 9% interest, or whatever our minimum attractive rate of return is. Whatever this 9% interest is, it's as if we put this 844, instead of putting it into the bond, we put it into something that earned a constant 9% interest. It would be equivalent to that. So that's how much we should be willing to pay for it. If we paid less than that, then we're going to have here in this calculation, it's going to be better than our 9% opportunity. If we pay more than $844 for that, then we're going to have a negative NPV in this case. It's going to be worse than our typical 9% opportunity. So here is the answer here. This here is just a calculation to show you why this is the amount we should be willing to pay for that bond. So if you buy the bond for $800 instead of $844, what's the bond yield? And for that, we'll turn to a spreadsheet. So here's my spreadsheet. I've got 9% interest, and here are my columns. As usual, I've got times 0 through 5. My discount factors I've calculated according to the usual present given future amount discount factor. Our cash flows are $50 every year, including the last year, and we have an additional $1,000 at the very end there. And we're assuming at this point that we're not buying the bond. We're asking how much we should be willing to pay for the bond. If you don't consider the purchase price of the bond, there's no cash flow at year 0, then you'll calculate a net present value. Let's, I guess, put these all as dollars. Then you'll calculate the net present value as $840.41, like we did by hand. Now we can take this net present value there. I'm going to copy it, and I'm going to paste special, right click and paste special. I'm going to paste the value of it. So let's make that negative. That just gives me all the decimal places. I'll make that negative, and we can see that the net present value becomes 0. And so we want to find the rate of return now if we pay instead $800. All right, so now this is our net present value at a 9% rate of return. But if we want to find the yield, if we want to find the effective rate of return, then we can find what interest rate makes the net present value equal to 0. In other words, what interest rate is the bond equivalent to. So to do that, we go to Data. We go to What If Analysis, Goal Seek. We'll set the cell, the net present value, to value 0 by changing this cell here. And Goal Seek found it. 10.32% is the yield of the bond.